Now next problem where value of theta is required under some condition. Find the value of theta if 3 plus 2 iota sine theta upon 1 minus 2 iota sine theta is a purely real. It's not a complex, it has to be real. For what value of theta? This is the problem. If I take, as clearly iota has been observed in the two places, numerator and denominator, so at this stage this is a complex number 3 plus 2 iota sine theta upon 1 minus 2 iota sine theta. If it is multiplied, numerator and denominator both, by the conjugate of the complex numbers, denominator, that is 1 plus 2 iota sine theta multiplied to numerator and 1 plus 2 iota sine theta is multiplied to the denominator. After multiplication, the value of z is coming as 3 into 1, that is 3. Then 3 into 2, 6 iota sine theta. Then 2 iota into 1 become 2 iota sine theta. And then 2 2s are 4. But because of iota square, this will be minus 4 sine square of theta divided by 1 minus 2 iota and 1 plus 2 iota. This become a plus b, a minus b, a square minus b square, which become 1 plus 4 sine square theta. So the z is coming in the form that is 3 minus 4 sine square theta upon 1 plus 4 sine square theta plus 6 sine theta, 6 iota sine theta plus 2 iota sine theta. This become 8 iota sine theta and common denominator 1 plus 4 sine square theta. We have to take the required condition that for what value of theta this complex number is purely real. For a complex number to be purely real, its imaginary part should be 0. Its imaginary part is, for purely real, what we need to take, imaginary part is 0, that is 8 sine theta upon 1 plus 4 sine square theta is equals to 0, which implies sine theta is equals to 0. But in general solution of sine theta is equals to 0, you can conclude that theta is equals to n pi. From the general solution of the trigonometry, the answer of theta will be n pi if sine theta is 0. As 8 sine theta upon 1 plus 4 sine square theta is 0, so after doing the calculation we will find sine theta is 0 and theta is n pi.